Hey everybody, welcome to notes number 24, the last lesson in our semester. In this lesson, we're going to take what we've been learning about linear equations and the coordinate grid and connect it to a couple more forms of a linear equation. Now, we've talked a little bit earlier about linear equations in what we call standard form. That happens anytime the x and the y value are on the same side of the equation. Now, this lesson is all about getting the equation onto the graph. So I'm going to recommend anytime you have graphing in standard form, in order to graph, I recommend using your intercepts. Remember that with intercepts, if it's an x-intercept, that's when I set y equal to 0 and solve for x. If it's a y-intercept, that's when I set x equal to 0 and solve for y, creating two separate points. Your other option is to transform it. The other option is to transform it into what we call the slope-intercept form. Slope-intercept form is any time I have my y value, my y variable, I should say, by itself. In slope-intercept form, I'm able to just read off my slope as the m value, aka the number in front of the x, as well as the y-intercept, which as an ordered pair is 0 for x, and then whatever number is by itself in the b spot. Remember that all I need is 2 points in order to graph my straight line. So we're going to look at both of these forms. If you start off in standard form, I recommend using xy intercepts. If you start off in slope-intercept form, that's a bit quicker for us because we get to just read that slope, read off that y-intercept, and go straight into the graph. So looking at number 1, I have y equals negative 2/3 x plus 3. Notice that y is already by itself. So this is what we call slope-intercept form. And we call it that because my slope can easily just be read off as the number, take that negative with it, the number in front of the x, negative 2/3. And then my y-intercept is the b term. Whatever number is by itself has 0 in the x spot, and in this example, the number 3 fills in that y-intercept, that y value. Just like we talked about in our last lesson, if I have y-intercept and a slope, I am ready to go into the graph. I always start with that point. 0 side to side, 3 up, plot your point. Then I use my slope to find another point. So my slope of negative 2/3. Remember, the top number is my rise. So the top number would take me up or down. In this case, down because of the negative. Over run. So the bottom number would take me left or right. Because it's positive, I'm going to move to the right. So from my y-intercept, I need to make both moves. Down 2, right 3, plotting another point. You have to have 2 separate points in order to draw your line. So thankfully, if we're already in y equals, if I'm already in slope-intercept form, that graph, it can just be read off. However, if we are in what we call standard form, notice in our second example, x's and y's are on the same side. So this is called standard form. And in this situation, I recommend finding x and y intercepts. Remember that an x-intercept is its own physical point. A y-intercept is its own physical point. And then I use those 2 points to draw my line. So to find your x-intercept, that's when I set y equal to 0. So let's do that down here. So for my x-intercept, I'm going to take 2x plus 4 and plug in 0. Giving me 2x. 4 times 0 is 0. So 2x equals -8. And when I divide by 2, x equals -4. Now we have to remember that the y coordinate was already decided as 0. The x coordinate we just found to be -4. I put those together as a single point, -4 for x, 0 for y. So the x-intercept itself is its own point. For my y-intercept, I just go in the reverse order. I set x equal to 0, and I find the y it connects to. So to find that y-intercept, this time I put the 0 in the x spot. So 2 times 0 plus 4y equals -8. Well, 2 times 0 zeros out, so I really have 4y equals -8. And when I divide by 4, it gives me a y value of -2. So you have to remember that those two values went together. The x that we forced to be 0 and the y coordinate we found to be -2. So 0, -2 gives me a second point on the line. Now there are other options. You could have taken your 2x plus 4y equals -8, solved for y and graphed, but please note that that often causes more problems, easier to make mistakes along the way. So the rest of this lesson is just practicing that. Remember that sometimes there are special cases. Looking at number 3, I have y equals -3x, and that's it. Now notice I do have y already by itself, so we're going to call this slope-intercept form, which normally takes the form y equals mx plus b. Because my x is already there, the number in front, that -3, is what we use for our slope. However, do we have a b value? Do I have a number that's being added or subtracted? No, I don't. So I use what's called the nothing number. My y-intercept in this case, always 0 for the x, but because I don't have a number written in, my y-intercept is also 0. Meaning I'm starting off at the origin. 0, 0 is my first point. When I go to use that slope, remember that slope is rise over run. But all they gave me was a -3. If all you have is a single value, any number can always put a 1 underneath it. We need to bring that 1 in so that we have a rise value and a run value. It takes both moves in order to find your next point. So -3 on top tells me I should go down 3. A +1 on bottom tells me I should go to the right. Remember that any rise takes me up or down, any run takes me right or left. So from my y-intercept, I go down 3 and right 1 to plot my second point. And 2 points is all it takes to graph the line. So notice that in this case, my b value disappeared. But b can always come in as a nothing number where I add in 0. For number 4, I also still have slope-intercept form. I already have y by itself, so y equals mx plus b is what we're focusing on. But this time, notice what disappeared. I have an 8 by itself, so that's what we'll use for that b value, or my y-intercept, 0, 8. However, this time my m disappeared. My x value disappeared. So this would be the same thing as nothing x plus 8. Remember that a slope of 0 is one of those special cases. Miss Brazel can ski on a flat surface. It's just 0 fun. So in order to graph an equation like this, I'd still have 8 as my y-intercept, but I draw a line horizontally through that point. Notice I'm actually cutting the y-axis. And anytime you see y equals and just a number, it's going to end up being that special case where I cut the y-axis at that number. If you have the other special case, notice here I only have an x value, an x variable. Where in the previous example, I only had y equaling some number. If y equaled a number, then I cut the y-axis. However, if all I have is that x equaling some number, then what it is giving me is an x-intercept. At that number, x equals 2, and then I cut the x-axis at that value. So this time I'm going to cut the x-axis instead of the y. This is a case where my slope, my m, was undefined. So you have actually now seen all of the scenarios. You've seen y-intercept, you've seen slope y-intercept form, you have seen standard form, you've seen what happens when your b disappears, your m disappears, or that special case where all I have is an x. There's still one more example on this page that we're going to go through. And then the rest of this lesson is just practice. So let's go and do example 6 together. Now example 6 shifts gears a little bit because notice I have it looking a little weird. I have x, I have y, they're on weird sides. They're not together. But what else I notice is that at least I know that y is not by itself. So this is not slope intercept form. I can't just read off a slope and y-intercept to move straight to the graph. So in these cases, if I do not have y by itself, it is recommended to find two specific points, the x-intercept and the y-intercept. So let's go ahead and do that. To find the x-intercept, that's when I set y equal to 0, and I find the x that goes with it. So I have 3x equals, rather than 2y, I have 2, plug in 0, plus 6. When I solve for this, 2 times 0 is 0, so I have 3x equals, well, 0 plus 6 is just 6, and divide by 3. X equals 2. Now remember, these two values together create a single point. You have the 2x value and the 0 that you forced, giving me an x-intercept, a point on the x-axis at the number 2. I also turn around and find the y-intercept because I need 2 points to form a line. To do that, I set x equal to 0, and I find the y value that goes with it. So I have 3 times 0 equals 2y plus 6. Well, 3 times 0 is 0. And then my focus is to get y by itself. So I'm going to start undoing the things that are around the y. I'm going to subtract 6 to the other side. Not sure why it's blinking at me. And divide by 2. Giving me y equals negative 6 divided by 2 is negative 3. And together, the 0 you plugged in and the negative 3 you found create another ordered pair. 0 side to side, negative 3 down, and connect your dots. Good. So how you go about this just depends on what you start off with. If y is already by itself, go slope-intercept. That's the y equals mx plus b, where you read off the slope that's in front of the x. Whatever number is in front of your x creates the slope, the rise and the run. And the number by itself is your y-intercept, which means 0 side to side, and in this case, negative 3 on the y-axis. Just like we've done over and over and over again, you have to have your starting point. So I plot that y-intercept first. Then I use the slope to find another move. Positive 1/4 means I rise up 1, run to the right 4, plot another point. And you could keep going, but it only takes 2 points to plot a line. If y is not by itself, then we use standard form. You're in standard form in this case. That is when I recommend using your x and y-intercept. For my x-intercept, that's when I set y equals 0 and I find x. So in this case, I have 3x minus 0 equals negative 6. My 0 disappears, and I divide by 3, giving me x equals -2. -2 x value, 0 y, and I have my first point. For my y-intercept, that's when I set x equals 0 and find the y value. So I have 3 times 0 minus y equals -6. But 3 times 0 zeros out. And 0 minus y, the 0 just disappears. But in order to get rid of that negative, remember that's a -1, I have to divide the negative to the other side. You're not done until y is positive and alone. But once you have that, you have a second point. 0 side to side, 6 up, 2 points to plot your line. And you've essentially covered everything you need for this semester. I'm going to stop this video here, but notice there are 6 more examples that I would like you to practice before you watch the next video. Some of them might throw some fractions at you. It's okay. You can handle it. I know you can. But with that, I'll leave you for this video. Practice it. Second video, we'll walk through our last 6 graphs.